Let's look at Polymath and its uses in chemical engineering. Polymath is a program which is being developed by chemical engineers, uh, developed by Michael Cutlip and his team, and it is, I think, one of the very easy program which helps you to solve mathematical models in chemical engineering. Basically, it covers four different kinds of equations, or you may say codes or solution. The first being system of linear equations. This is system of non-linear equations. This is ordinary differential equation, and this is regressing the data when we have got experimental data and we want to fit that to a model. Now today we are going to see the use of system of linear equation. uh, See, the moment you click it, the spreadsheet like tool will appear and we have to enter the data. Say for example, our there are three equation and three unknown, and say we hypothetically enter some data, and say we have got so this is taken as 3x1 plus 9x2 minus 3x3 equals to 5, 2x1 minus 5x2 plus 3x3 equals to 10, 5x1 plus 3x2 minus 2 equals to 5. This is how we can read this as an input, and we know that many times we encounter such a linear set of linear equations in chemical engineering. So when you enter this data, just press on this arrow and Polymath gives you everything. So this is the equation, or these are your x1, x2, x3 value. This is the equation which we have entered. This is the matrix, and this gives you the number of equations. So it's so simple that you just need to enter the data and press on the arrow. No programming, no coding is required. You can add any number of equations, you get the solution. Say for example, I extend this to 5, it will give this. So I may change these values to 6 3 0. Say this is 2 5 4 minus 3 4 4 5 12 6 minus 9 8, and let's say 7 5 2 minus 4 6 2, and we press enter, and these are the answers. So whatever you enter, you get the answer very easily. So any set of linear equation you can solve using Polymath. This is related to and you can still, you can save this program, and if you can just you want to just start a new function, you can just start a new function. So for example, we have a system of non-linear equation, so we enter a new program, and you can just add the function which you want. Say for example, we have already got the function in front of us. So suppose this is our function wherein we have got van der Waals equation. Pressure is known to us, temperature is known to us, A and B can be calculated, and we want to find out the value of V. So let's say we try to solve this problem by putting this as the equation. The equation which we want here is this minus RT equals to 0. Our equation should be FV equals to 0. So I write equation as P plus A upon V to the power 2 into V minus V minus R multiplied by T. And let's say we write it like this, and we have to give some initial estimate, which is ideally an ideal gas equation, that is PV is equal to RT. Here we will write 0.5, and we may write van der Waals equation. So our equation is there. Now there are so many unknowns in this equation, so we have to give explicit expressions. Our pressure value, which is given to us in this case, is 56 atmospheres, or write 56 into, in comment you may write the unit. You may add one more, temperature. Temperature is 450 Kelvin, so 450 Kelvin. We may add TC and PC, and then we can calculate A and B. So we may add TC. TC is 405, so 405.5 Kelvin. PC is 111.3 atmosphere, and then we can add A equals, no, we have to still add R. R also given to us. R is 0.08206, and the units are atmosphere, liter, gram, mole, Kelvin. Then we have got A. So A can be calculated by the equation given here, that is 27 by 64 multiplied by R square into TC square upon PC square. Same way we can add for B equals R into TC upon 8 into PC. So these are our van der Waals constants. So we have defined everything, right? There is no nonlinear equation 1, auxiliary equation 7, and we have not given any upper gas. So we might, like, before we can move further, we have to give initial and final value. So minimum value of V 0, and maximum value of V we can say 200. This will limit the iterations between this, and you can just see that after we have submitted all this information, this arrow is highlighted. So we have got initial, like we have got the range. These are the AB value, AB constant, R, PC, TC, T and P, and once we get all of them, the this function can be solved. Our initial estimate for V0 is 0.5, so based on that, Polymath will start iterating, and eventually it will come to the solution for V, for which this function is 0. So we have to just press this. We may have some issue here. Might need to modify the equation as it is. This we may have to. This may. And see since it was V was in denominator, it was facing some issue, but this is how you can get the value of V, and this is the function. These are the values which we have got, and this is how you can solve a non-linear equation, single variable non-linear equation for van der intervals equation using Polymath. So Polymath is a very simple tool. If once you enter all this, you can get the system of linear equation, system of non-linear equation. This version of Polymath also comes with inbuilt example, wherein here it is a quadratic equation, same SRK equation, pipe diameter, and these are all for this particular section. If you go to this and you go to examples, you get linear equation. Same way, if you go to ordinary differential equation, say for example, and you go to example, you will get example related to ordinary differential equation. And for regression, there also you got example, you got example for this. So we can use this inbuilt example to understand this in a better way. Next time we'll talk more about ordinary differential equation and regression analysis. Thank you.